Welcome back to the second episode in our series of how to design bikes using CAD software. Today we're going to cover configurations. So we're using OnShape as our CAD platform. In the last episode, and I'll put the link in the description below in case you haven't seen it, we covered how to piece together the basic fundamentals of a geometry skeleton for any sort of bike, whether it's a mountain bike, road bike, full suspension, rigid. It's all covered in there. Today, essentially, what we're going to cover is the use of configurations within that geometry skeleton to allow us to have multiple sizes of bike, and we'll also touch on how we use that for suspension, to have it in multiple positions that might be useful later on down the line when it comes to designing the products. So we'll open up our file. I've done a little bit of work on this just to prepare it. So essentially, we're starting off where we finished the last video. So within this master geometry skeleton, what we're going to use actually is a bike from Orange. So it's a stage 6 just for this example, and I'll explain why later on. So essentially, this is what we got to with the last video. We've got our fully defined geometry skeleton with all the useful information. It's not got all the information, but it's got the fundamental and essential information to help progress to the next step. So like I say, if you didn't see that video or you don't understand everything you see on the screen right now, go back, watch episode 1. It's only 15 minutes long. That'll get you up to speed. So what are we going to do today? We're going to talk about configurations and essentially why that's useful. Why is it useful to have configurations? It allows us to have multiple sizes of frame because every bike comes in more than just one size, or most bikes do. So it allows us to use configurations to flick very quickly between different sizes of bicycle, which will then allow us to design parts and control our assemblies later down the line. So how do we do that? And why is it important? First of all, this is your sketch. You'll find within OnShape a configuration panel on the right hand side. So what you're going to want to do, and what configurations are essentially, are they allow you to control some of the critical information that's within a sketch. So we'll configure this part studio, and again within OnShape this is a part studio working in, so we can draw, we can sketch, we can extrude, we can take sketches and turn them into solids and surfaces. It's not an assembly file. We've also brought in some other useful information, such as the geometry table. So we've gone to the Orange Bikes website for the model that we're going to want to analyze, and it imported the geometry table from that. So that's where we'll get our information that'll later on be put into our configuration. We also got some side view sketches, again readily available on most manufacturers' websites, and occasionally a full photograph of the bike. And again, I'll explain why this is important later on. So we've got our basic geometry, and what we've done is essentially started with the first size. So generally if you start with the smallest size, it's good practice, and then you can configure the other sizes from that. If you have one particular favorite size that you want to start with, that's also fine. You can make that, say it's a size medium, you could make that your default, and then you could configure either side from there. So we're in configurations. Well, you have to be out of a sketch. You have to be not in an active sketch when you start this process. So go into configurations, configure part studio. The first thing it's going to do is ask you, well, what are you going to call these things? So what we'll do is we'll rename default and we'll call it size medium. We're also going to do size large, and we're also going to do size XL. We can see that information in the geometry chart that we imported. They don't have a size small, and they don't have any. They've just got 3 sizes for this particular model. So these are the configurations that are going to be available. Once this is all complete, you'll see these pop up. In fact, already you'll see these pop up here. So it means that you can flick between each of the sizes, and all of the data that you then configure will change within the part studio. So we've told the computer, we told the software what our parameters are. We now want to configure the first dimension or the first piece of geometry. So we'll click into configure features. It's now asking you to select the sketches or features to configure. So the first thing you have to do is tell it which sketch. Now we've only got one sketch active at the minute, so we'll click on that sketch. So it knows that there's a dimension in this sketch that we want to configure. It's now asking you you know, it's not giving you any more information. It said you've selected that geometry. What it actually wants you to do now is pick one of the dimensions that you want to control. So the first one we're going to select is the reach figure. So we'll click on that, and you'll see straight away it highlights that in a sort of perforated orange box, and it's now transferred it into your configuration table. You can either do one of two things now. You can go through and change that based on the geometry, or you can add in the other things that you think might change. So we'll go through and edit these. So they're all set as the default, which is what was programmed in when we created the geometry at the start. So we know that this is correct for a medium because we can reference our geometry table that we've downloaded. If we scroll down, you'll see reach here. So we need a 468mm reach for size medium. We need 487 for size large and 505 for size extra large. So we'll just type those in. So we've got 468 for size medium. Size large is going to become 487. So just type that in, hit enter. And for extra large, it's 505. So that should be it. You're not in a sketch anymore, and you can test that theory. You can hover over these to make sure that something is changing. And then again, if you want to flick between your configuration panel on the top left to size large and size extra large, you can see subtle movements in the front triangle growing. So we know it's working. So let's flick back to size medium, which is our default. The other items that are different between sizes of this particular bike are going to be the head tube length and the seat tube length. There's very little else changes on this particular model. Some bikes have lots of differences in the geometry, but this is a good example because it's quite simple for the purposes of this video. So we just repeat the process. So let's say our head tube is going to change. We know that on size medium and large it's 110, but the size extra large is 120. So again, follow the same procedure, configure features. It's this sketch we want to use, and we just click on this head tube measurement. Again, by default, it's already set to 110. We don't need to change these two, but on the extra large, let's make that 120. Again, we can test it. Does it look like it's growing? You can just click on that line and you'll see, zoom in and click on that line, you'll see a measurement of 120 there. So we know that that's working. Is it still working on this? 110, yeah. So again, repeat the process for the final piece, which is the seat tube length. Now, Orange have specified their seat tube length in inches. You'll see it here at the top. So we've got 17, 18, and 19. So OnShape's pretty clever. It'll convert that. So what we've done is 17 inches times 25.4 millimeters per inch, and that'll give us the appropriate measurement. You can change the units in your OnShape document, but it changes the units for everything. So you could set everything to inches, but then all these other dimensions. So for the purposes of this seat tube measurement, which is the only one that's going to be specified in inches, we'll just convert it using a formula. So again, just go in, change this one to 18, and on the extra large, it's 19. Again, you can constantly reference your geometry table that you've brought in, and that should be it. So again, we'll do a final check. Does it look correct? Is the seat tube? You can see we generally use a point to determine the seat tube length because it's not always on the actual seat tube line. Sometimes there's an offset, which again we covered in the last video, so we use a point. But for the purposes of this frame, I think it is generally a straight line from the BB, which is quite handy as well. So yeah, everything looks like it's working. So we've now got our three sizes. There's very little information or other information on there that's different. Everything else is pretty much driven. So there are some measurements, obviously, such as top tube length and effective top tube length in the cases of this bike, wheelbase, all those things, they'll all change, but they're not determined by the configurations. Essentially, these are all set. You'll see here we've got obviously a fixed driving dimension in black, and then in grey these are dimensions that are driven, so we can cross-reference those with the geometry chart to make sure that everything's correct. Before we move on, we can also, so that's our configurations for our sizing. We're also then going to use configurations in a second to talk about how we can control the suspension if it's a suspension bike, which can be really useful for clearance checks later down the line once we get a little bit more into the design side of things. But before we do that, I just want to touch on a point so that it's, I guess, so that you can be aware of it. I showed you that I brought in some images, some side shots of the bikes. That can be really helpful, but it can also be a hindrance because they're not always accurate. So for example, I'll roll this down and I brought this point in. So I wanted to draw the suspension points on this bike and have them, laid over an image so we could get them roughly right. Most people don't know the exact dimensions for every different bike for all the kinematics and suspension points. That's obviously each manufacturer's intellectual property, so it's not readily available, and it shouldn't be. So occasionally, if you were designing a suspension bike and you wanted to design or replicate a suspension platform, you could use a side photograph to get roughly there to help you compare maybe some competitors' products against your own. What we did on this was I imported this side view sketch, which again was downloaded from the manufacturer's website. But what you'll find, or what we found, is first of all, it might not be this. You don't know what size of bike they've used for the image. So you can see here we're on a medium. You can see our geometry chart in the background. The head tube doesn't quite line up. So straight away, something's not quite right. It's obviously not a medium image. And also this is stage 6. This image came from the page of the model that we're modeling, essentially. And you can see straight away, like, this should be our rear axle. There's quite a difference there. So what I suspect, and is probably quite common across many brands, is the image they've used is just a generic frame image, and they've put it on because it doesn't, it has the information it needs. It doesn't need to be super accurate. So this isn't a criticism by any means. And I know this goes on with lots of different brands. So we can't really trust that image if we want to try and get, the main pivot position. So we'll turn that off. The next thing I did was import an image of the complete bike, which we know should be a little bit more, not accurate, but it is the right bike. It has the right specifications. But the problem is, because it's a side-on photograph, you'll never get total accuracy on this. But straight away, you can see that the geometry starts to look slightly closer. We can overlay and move the image slightly, but it's impossible to get a true side view of a bike just with the way proportions work. But, we've scaled this and moved it around and got it quite close. We want the BB to be hovering over our origin, and then we can see that our rear axle is not too far away and front axle is not too far away. Again, the head tube is a little bit forward of there. So, and I have no idea what size of bike they used when they photographed this. So it might be a medium, it might be a large. We can flick to large and see if it looks kind of similar. It could be, the seat tube stops at the right place, head tube looks a little bit closer, but who knows? Ultimately, it's not overly important right now, because we're not trying to, replicate this bike overly accurately. We're just trying to, I guess, get the principle of configurations across. So anyway, the reason this bike image is here is I want to show you how we can configure the suspension system. So the first thing we do once we brought the image in is we start a suspension sketch. So again, we tend to have two files. We've got one that's fixed with the geometry or the dimensions. That's always fixed, and that's the one that you would, if you were an engineer working for Orange or working for any bike company, you would have this information. You would have designed it and developed it and modified it to suit clearances and things like that. So we create that sketch, make sure it's fully defined, and you can see it's 210 millimeter shock. This is a 140 mil bike, so we'll see that in a minute. The next thing I do is create an additional sketch, and I guess everybody does this differently. But what that allows us to do is and it looks identical, but actually it's not defined. If we take this away, it's totally floating in space. The only points that are fixed are the main pivot, and it's coincident with the master kinematics and this front shock mount. Those are the points that are fixed. So as the suspension compresses, obviously you can tell that that's what's going to happen to the rear end. So let's set that back. We stick a dimension on the shock, which will be the fixed shock length, so that's 210 millimeters. And again, what we'll do is accept that sketch. Now we've got a dimension that we've just added in here, so if we want to configure this so that we can see it at full extension in its static position, or we can see it in its compressed position when the shock is fully compressed, that's the configuration we want to do, so that we can flick between not just sizes but also shock position. So it's a new configuration, so we need to add a configuration input. It is a list, I believe, and we can rename these, so it's useful once you get in a little bit deeper, you can rename these. So let's rename this and call it suspension, and we'll rename this one and call it sizing. Okay, so sizing, we've got medium, large, and extra large. In our suspension, we're going to rename this and call it static, and we're also going to have another version, compressed. So those are the two that we want to do. So really the only difference there will be the shock length. So we'll go in like we did at the start, configure feature. Which sketch is it that we want to modify? It's the suspension sketch, and it's the only dimension in here. So we'll click that. So 210 mil, what we need to check is the shock specification. So again, we should have that in here somewhere. Again, downloaded from the manufacturer's website, we can see that the shock length is 210 millimeters by 55 mil stroke. So essentially in the compressed state, again, we can use a formula. So it's going to be 210 minus 55 millimeters. Let me press enter. And that should be it. What you'll see now again under our configurations tab in the tree is all of our size runs are still here, and we've now got this option of static or compressed. And if you flick onto compressed, you'll see that the rear triangle, we'll just close this window, the rear triangle has now moved into a compressed state. That's really useful visually, but also from a clearance point of view. You know, we can model a rear tire in there, make sure that we've got clearance against seat tubes. All those kind of things are important. We could, you know, there's no limit really to how many configurations you can have. I think you can have as many as you want. So if you wanted to, you could have a front fork compressed or uncompressed. You could do all sorts of things, saddles, seat posts, all that stuff. But these are the more critical ones that are kind of, it's hard to move forward without these in place. So again, just testing everything works, making sure that all sizes, they're independent, so the sizes shouldn't, you know, affect this, if that makes sense. So that's pretty much it for now. We've got everything functioning the way it needs to. We can turn off our visuals, our images, and we're left with this file. So the next steps from here, essentially you've got your geometry sketch in all sizes, you've got your suspension layout. The next step from this point would be to start doing some clearance or compliance checks with components to see what spaces you can and can't work within, and then from that point forward starting to design the bike. So yeah, that was episode 2. Thanks for watching, and yeah, we've got lots more content to cover. This is still very early days, but in the next couple of episodes we should start to piece together a new bike. So do we continue on with the orange stage 6? I think that's maybe not a bad idea. If you've got a different bike model that you think we should use to model this out, let us know. But yeah, thanks, and we'll see you on the next one.